So hello everyone and welcome to Developers and Coders Club and Integral Class YouTube channel. My name is Akshat Kumar Verma and today we'll be discussing this problem number C, two arrays which came in the Codeforces around 755 division 2. So first let us read the problem statement and then we'll try to get an intuition of how to do it and then we'll implement it. So we are given with two arrays of integers A1, A2 like A array and B array, and both the arrays are of size n as we can see. So let's define a transformation of the array A such as that choose any non-negative integer k. Okay, that basically means that it is greater than 0 and less than n, and choose k distinct array indices. Okay, then we need to choose k distinct array indices. They are not same, and then we'll add 1 to each of the indices that we chose. For example, we'll add 1 to each of these indices, and all the other elements of a remain unchanged. And we can permute the elements of a in any order, so we can basically rearrange it as we want. So what is that we have to do? That it is possible to, is it possible to perform some transformation of the array A exactly once so that the resulting array is equal to B? Okay, so we need to make a one shot kill, like it is only just exactly once. We can do this transformation, that select k indices and then add 1 to each of those and then permute them in any order. And we need to make array A equal to array B. Okay, now this is the input format. It will first contain test cases and then the usual input, and for each test case we need to output yes or no. Okay, so for each test case, if it is possible to make B from A, we'll output yes, otherwise we'll output no. First let us see some example test cases like this one. So basically it is given us to, this is the A array, this is the B array. So if we choose these two indices like -1 and 1, okay, k value will be 2 and the indices will be minus this index 1 if we consider 1 based indexing and index 2. And now if we add 1 to it, this will become 0, this will become 2. Okay, and then after we permute it, rearrange it, it can become equal to 0 0 2. Now consider this array. Okay, it will be of size 1. The first array just consists of a single element 0, and the second array is of size size 1, and the value of its only element is 2. Now if we add 1 to it, it can only become max 1, it cannot reach 2, so our output is no. And this array, these two arrays are exactly the same, we don't need to make any changes to it, so we just outputted yes. So what we have gathered till now is that we need to make elements of this, each element of this equal to this. Okay, so what is the way to do that? Now for example, let us consider that I chose an index like 2, and I will try to make it equal to some other element, any other element, because we can rearrange it. So how can I ensure that while making this element equal to some other element in this B array, I don't compromise with some other element? Like for example, if I chose A2 and made it equal to B2, but A1 was also be able to make B2, because A1 and B2 were equal, but A2 was one short from B2. So in this way, I just compromise that this element would not be able to make B2 now, or this won't be of any use. So what is the best way to ensure that? So the best way to ensure that is basically sort the two arrays. Now, so first we will sort both the arrays A and B, right? Now in that what will happen? Let us consider some, okay, let us consider some example like this one, -1 1 0. Okay, what is this? -1 1 0, and the second one being this 0 0 2. Now after sorting, what will this array become? This will become -1 0 1. This will become what? 0 0 2. So now what will be our idea will be? So we know that for each element of A after sorting, it should become equal to the corresponding element in B. Okay, that's the only way to ensure that we are not hampering with like possibility of some other element. If we sort it, then we know that this element is the nearest to the corresponding element in B. So we can ensure it in that way. So now we'll traverse in each of the element after sorting. This is A array, this is B array, and now we'll traverse in both of the arrays simultaneously in a single for loop or any loop, and then we'll check if this element, the element in A, we can write it as AI if I is the current index. If AI is equals to BI, then we don't need to make any changes, right? Because there it is already equal. Otherwise, if AI would be equal to, let us consider bi -1. Okay, if it is bi -1, then we can like increment k like we don't need to actually increment it, we'll talk about it, but we can increment k and include this element in a subsequence that we needed to, like this, what we call it, we have to choose k distinct indices, so we'll increment k and add this element to that one if ai is equals to bi minus 1, otherwise this case. And if both of these conditions do not hold, what will we say? That okay, it is not possible. Why am I saying it is not possible? Because just now we proved that we have, after sorting, this element will be the closest to the corresponding element in B, and if these two conditions does not hold, then it is not possible to make array B from array A, because if even if we try to make it from other element, then that other element will not be equal to corresponding element in B. So this was the only simple observation that we had to make, that if for any index I after sorting, if these two conditions does not hold, then we will set a flag variable, right? We can set a flag variable, and if flag variable is true, then we'll output yes, and if flag variable was set to false in between the loop, then we'll output no. So let us see the code that I submitted during the contest. Okay, so this is the code. First I will input take in the number of test cases, then I will take in the number, the size of the array, then I will take in both of the arrays, and this is the STL function for sorting. Okay, now this is the flag variable that I talked about. It is initially set to true, and if any condition occurs where ai is not equals to bi minus 1 and ai is not equals to b, so this could also be written in a better way, something like, for example, let's say if this if condition, we could just this loop could be written in a better way. We could just write if array I is not equals to b array of I, and both the conditions do not hold, basically is not equals to bi minus 1. So we don't need to write this continuous statement or something. In a hurry I might have written that, but this would also work. This is the best way to do it. Now whenever we encounter an element in which both the conditions do not hold, I just set the flag variable or check variable to false and break the loop, and then at the end I check. If check is still set to true, then I will output yes, otherwise I will output no. So this is basically a bool variable. If its value will be true, then this condition will execute, otherwise this condition will execute. So this was it for the problem, and if you want to talk about the time complexity of this one, so this is basically a big O of n loop. Okay, you can see we're just traversing both the arrays in a single loop in n time. These two are also big O of n loops, but these sorting conditions, these sorting statements are of n log n time. Okay, this will take n log n time, so we can say the time complexity of this solution will be n log n, big O of n log n. Why am I saying big O? Because there might be other elements like plus n, plus log n again, n log n again. So that's why it will be big O of n log n, and space complexity will be basically big O of n, because we're just taking in two arrays for sorting them purposes. So this was it for the problem. If you have any doubts, you can post it down in the comment section. And thank you. This was it for the video.